Those were real voices, real men, real emergencies, real fear, broadcast across 238,000 miles of empty space to a room full of engineers who had no idea if they could help. The Apollo program is the most celebrated achievement in human history. 12 people walked on the moon. 6 missions landed. 1 billion people watched. But behind every triumph was a crisis that could have ended everything. A fire, a lightning strike, an explosion in deep space, a computer that failed 60 feet above the surface of the moon. These are the moments NASA never put on the poster. Let's go back to where it all nearly fell apart. July 20th, 1969. Neil Armstrong and Buzz Aldrin are inside the Eagle, the lunar module, descending toward the Sea of Tranquility. Walter Cronkite is on television. 600 million people are watching. And then, 3 minutes before touchdown, an alarm goes off. Error 1202, then 1201, over and over. The guidance computer, the machine controlling their entire descent, was overloaded. It was receiving more data than it could process. It was, in the most literal sense, about to shut down. A 26-year-old NASA engineer named Jack Garman had to make a split-second call. Abort or go. He said go, but that wasn't the end of it. As they got lower, Armstrong looked out the window and saw the autopilot was flying them straight into a crater the size of a football stadium. Surrounded by boulders large enough to destroy the lander on contact, he took manual control, with the computer still throwing alarms, with the fuel gauge dropping towards zero, with mission control watching in silence because there was nothing left to say. The Armstrong flew the Eagle over the crater, cleared the boulder field, and set down. With 25 seconds of fuel remaining. 25 seconds. One extra moment of hesitation, and we never land on the moon in 1969. Maybe never. But here's what almost no one mentions: the return. Back inside the Eagle after the moonwalk, Armstrong and Aldrin discovered that the circuit breaker for the ascent engine had been snapped off. The switch that was supposed to ignite the engine, the only engine that could lift them off the moon, was gone. Buzz Aldrin found a felt-tip pen in his flight suit pocket. He jammed it into the broken housing. It completed the circuit. They got home because of a ballpoint pen, and when the command module splashed down in the Pacific, it immediately began rolling upside down, taking on water. The crew had to inflate recovery balloons just to right themselves before rescue divers arrived. The most celebrated mission in history nearly ended 4 different times. Nobody should have launched Apollo 12 that day. It was November 14th, 1969. The sky was overcast. There was a light rain. NASA's own weather rules said launches should be scrubbed in those conditions. They launched anyway. 36 seconds after liftoff, lightning. The Saturn V rocket triggered a massive strike, then a second one. 16 seconds later, inside the capsule, every warning light on the panel lit up simultaneously. Electrical systems went offline, the fuel cells died, the guidance platform began tumbling. If the crew couldn't recover the systems in minutes, the mission was over. And depending on what had failed, so were they. One controller in mission control, 24 years old, remembered a nearly identical electrical signature from a ground test a year before. He remembered the exact switch that had fixed it. Almost no one in the capsule knew what that meant. Lunar module pilot Alan Bean found it, flipped it, and the systems came back online. Apollo 12 continued to the moon, but NASA had more secrets than that. During the landing, an engine showed abnormal readings. NASA's engineers knew. They didn't tell the crew, worried about panic on a mission already running on nerves. The surface camera was accidentally aimed at the sun during setup and burned out within minutes. All live footage from the lunar surface, gone. Primary photographic film was damaged in recovery. Some of it was never fully retrieved. Apollo 12 succeeded. But the crew didn't learn the full story of their own mission until years later. April 13, 1970, 200,000 miles from Earth. Jim Lovell, Jack Swigert, and Fred Hayes are 2 days into the flight. Everything is routine. Swigert flips a standard switch, the kind that gets flipped dozens of times per mission without incident. He's stirring the oxygen tanks. An oxygen tank carrying a manufacturing defect that had survived every inspection explodes. 2 of 3 fuel cells die immediately. The remaining oxygen tank begins venting into space. The command module is losing power. Jim Lovell looks out the window and sees the gas trail stretching behind the ship. He knows immediately they are not going to the moon. The question is whether they can get home at all. The only lifeboat is the lunar module, Aquarius, craft designed to carry 2 men to the surface and back. It had never been intended to support 3 men for 4 days. The crew moves into Aquarius and shuts down the command module to preserve its batteries for the one moment they will need it: re-entry. If those batteries drain, they burn up in the atmosphere, and then the problems compound. The carbon dioxide scrubbers, the filters that remove the CO2 the crew breathes out, are running out. The command module has spare canisters, but they are square. The lunar module's slots are round. Engineers in Houston have 4 hours, using only materials available on the spacecraft: plastic bags, cardboard, duct tape, and a sock. They design a makeshift adapter. They photograph it, radio the instructions up, and the crew builds it by hand. It works. But the cold is becoming its own crisis. Temperatures inside the module fall to 38 degrees Fahrenheit. The crew cannot sleep. Water is rationed to 6 ounces per man per day. Hayes develops a kidney infection. On April 17th, 4 days after the explosion, the crew powers up the battered command module, not knowing if the cold has damaged the electronics, not knowing if the heat shield survived the blast. They re-enter the atmosphere. All 3 men splash down safely in the Pacific. NASA would call Apollo 13 a successful failure. The moon was never reached. But 96 hours of human ingenuity under maximum pressure brought 3 men home from the edge of the void. That is its own kind of achievement. We have talked about the missions that survived their crises. This one did not. January 27, 1967. Gus Grissom, Ed White, and Roger Chaffee are inside the Apollo 1 command module on the launch pad. Not for launch, but for a routine test. The capsule is pressurized with pure oxygen, a normal day. At 6:31 in the evening, a spark, most likely from faulty wiring beneath Grissom's seat, ignites the atmosphere. In a pure oxygen environment, fire does not spread the way it does in open air. It detonates. The hatch, deliberately designed to resist opening in space to prevent accidental depressurization, took at least 90 seconds to open from the outside under ideal conditions. Grissom, White, and Chaffee had no chance. All 3 died in under 17 seconds. The investigation that followed exposed systemic failures in NASA's culture: cost-cutting, schedule pressure, warnings filed and ignored. Grissom had raised his concerns, and he had picked a lemon from a tree and hung it on the training module. A quiet protest against a machine he believed was not ready. Nobody listened in time. The Apollo program was grounded for 21 months. The hatch was redesigned. It now opens outward in seconds. Pure oxygen was replaced with a safer mix during ground tests. The capsule was rewired, rebuilt, retested from the ground up. And every astronaut who walked on the moon did so because 3 men died on a launch pad in Florida. Because NASA was finally forced to confront what it had gotten wrong. That is the part of the Apollo story that never quite makes it into the highlight reels. 12 people walked on the moon. 3 died on the ground before the program launched a single human being. Others came within 25 seconds of fuel, within a ballpoint pen, within a sock and duct tape filter, within one engineer's memory of a test he had seen a year before, of never coming home. NASA is now preparing to return humans to the moon. New rockets, new suits, new landers, a permanent lunar presence, and eventually, Mars. The dangers have not gone away, they have evolved. The vacuum is not more forgiving now than it was in 1969. The physics do not negotiate. So was it worth it? Was it worth the fire on Pad 34, the terror of 4 days in a freezing lifeboat, the 25 seconds above a boulder field with a dying computer? I will tell you what I think. The answer is in every engineer who worked 96 hours straight to bring 3 men home on a broken ship, in the 26-year-old who said go when no one else was sure, in the astronaut who jammed a pen into a circuit breaker 238,000 miles from home. The danger was never the point. The point was, we go anyway. That is what makes it human. If you made it this far, you just lived through 6 moments where history could have broken completely differently. Drop a comment right now. Which moment hit you the hardest? The pen, the lightning, the sock filter keeping 3 men alive in deep space? I read every single one, and I want to know, if you want to hear the real mission control audio from Apollo 13, all 4 days of it, I have linked the full NASA recordings in the description. 30 minutes of the most intense problem solving ever captured on tape. And if you are not subscribed yet, we have a video coming next week about the Soviet space disasters that were kept classified for decades. About cosmonauts who died in space, missions erased from history. You are not ready. Hit subscribe, hit the bell, and I will see you there.